Everybody, it's Tyler here at the Texas Cup, starting out with team number 2714 BBQ out of Dallas, Texas. This team here, Industrial Design Award winners in 2020 and 2021, and also won the Greenville District event in the 2020 season as well. This is a modified 2020 robot, and to help us tell us more about this robot is going to be Allie, Carly, Rhea, Adam, and Sydney. And we're going to be going through the entire power cell journey as we go through, of course, up and into the shooter, climber, some electronics, all this and more coming up on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or a career that supports you being in FIRST, check out careers.stryker.com to learn more. If your team or organization is hosting an off-season event, did you know you can stream it right here on FIRST Updates Now for free? Events that stream on FIRST Updates Now receive an additional 25 to 100% additional viewership because we help you promote your event on a large platform. If you're interested, reach out to us on any of our social platforms, on Discord, or send us an email at admin@firstupdatesnow.com. Let's get your off-season event streaming on FIRST Updates Now. Hurry, dates are booking fast, and we take first come, first serve for all our events.
So, Allie, we're going to be starting out with the intake on this robot. I'm very curious to hear about your wheels that you selected on here, how you go from these compliant wheels to these wheels back and forth. So tell me a little bit more about the concept and design and any iterations you went through as well.
Yeah, so we tested pretty much every type of compliant wheel, every different amount of squishiness,
Sure.
And every different radius, diameter, and we found that these were the most successful because we have these ones who have a little bit of compression, but these smaller ones, and so it allows this harder surface, allows the balls to come in when they're squishier, gets a better hold on it, and traps it in between the bumper and here. And having this smaller diameter just allows the ball kind of more room for freedom and just get in better. That's what we.
So are you noticing that the power cells actually, do they actually touch these as well too?
Honestly, I'm not sure.
Yeah. Well, we'll see it go through in a little bit.
Yeah.
As well. And talk to me a little bit more about these rollers up here as well.
Yeah. So we also tested with these. We tested compliant wheels, all sorts of stuff. These ones are much more squishy.
Yeah.
These ones are much more rigid. They're actually aluminum tubing, and then we custom 3D printed plugs and have hex shafts going through them. And we just found this rigidity worked a lot better to guide it through. We ended up doing this 2021 modification where we added this floating roller on top because in 2020 we had some issues with balls flying out of either, we had a standoff right here, so
Yeah.
this area, or coming into the serializer and flying out. So that's why we also have this to try to minimize
Sure, yeah.
those losses.
That makes a lot of sense on that, and we've seen a lot of teams doing that improvement year over year, making sure the power cells don't fly out. So Carly's going to be coming up next, talking about this serializer in here. So talk to us a little bit about how it funnels. One of the things I really like to hear from teams, by the way, is how do you prevent jamming? So when you have multiple power cells coming in, what do you do to make sure that they're not just all getting bundled together as it goes through?
In order to prevent jamming, we often reverse the wheels. So instead of going this way to make them more jammed, we go backwards so that and X-take them in order to make them more in line with each other.
So are all these chained via one motor, so they're going to always turn the same way, or can you individually manipulate them?
They are all one motor.
Sure. And what made you choose these types of wheels on the serializer?
They have a lot of grip.
It's mostly about compression.
Sure, the compression on it, yeah.
Wanting to allow the balls to flow freely without pressing them in too tight, and that's why we have a switch to aluminum into the conveyor.
Well, that makes sense. Well, let's see a couple power cells actually coming up and in, and we can kind of see how that compression works in here. I'm excited to see just a different contact with that as well. So it seems to come pretty efficient. I really like, you mentioned this addition here, that seems to be working really, really well with that as well too. And that kind of leads us into our next area, which is going to be your conveyor system that we saw them come through. And Rhea, you're going to be talking a little bit more about that. So tell us about this whole structure, how it came to be.
I think the idea for the conveyor was to just make it as simple as possible in order to make it as consistent as possible, because with a flaky conveyor, everything else is unreliable. So it was mostly about simplicity. We kind of just have straight aluminum rollers. We fiddled around with belts and like the spacing of the rollers and like the compression, but I mean the aluminum was lightest. We ended up actually switching out a couple of these rollers for 3D printed ones because that was even lighter. It saved us a couple ounces. But the pulleys on the ends are custom pulleys, and we have belts separating 2 stages of rollers. So they aren't all like flowing in there at once and then getting jammed up at the top. And another thing that we have in here to prevent jamming is these brake beams. Which are little tiny sensors. I don't know if you can see them, but they're on the other side. And there's one right here, too, on the motor, and then one at the top over by the shooter. Those essentially further help separate the stages and kind of they sense how many balls are in each stage and keep them moving upwards. So if I am controlling the conveyor and I roll this downwards, the brake beam will sense them coming downwards, and if there's another ball here, it'll move it right back up.
Sure, that makes a lot of sense.
It's really helpful. It's been a great addition, especially filtering into the shooter to prevent jamming. But yeah.
How about from the when the ball has to do this angle of this turn here, right? Is that really the brake beams that are doing the most of it, or I guess how'd you come up with what this angle would be from a mechanical standpoint to make sure that you're not going to get that jamming?
The angle was mostly influenced by the compression that we decided we wanted all throughout the conveyor. Sure. So depending on like how we're turning it upwards, the compression would have to stay the same right here. And also, it made most sense to to break our stages up right here in the angle to prevent exactly what you would assume would be an issue, just like getting stuck right here. So the belts actually are broken apart right here and right here to kind of combat that.
Yeah, totally get that. Appreciate that as well. We're going to be bringing Adam next, who's going to be talking about, I know you're a shooter, and Adam, I'm not sure if there's anything from a programming standpoint. Rhea mentioned the beam brakes, so I'm not sure if there's anything else you want to mention from that standpoint.
Yeah, really the only thing with the beam brakes is we basically made like a logic algorithm to sort the balls in. So the first ball will come up to here and then sit in that vertical roller, the vertical part. And then the second ball, when it comes in, it pushes the whole vertical area up. So then that first ball comes there, and the second ball comes in here, as you saw. And then when we get a third ball, it just shoves it into the corner and does not run the vertical at all. And then the horizontal, just running indefinitely, pushes it into this first part of the vertical and then stops touching the ball. And then the fourth and fifth just sit in the horizontal and at the entrance.
Sure.
And that way we can have all 5 balls in the conveyor without any of them touching, so we prevent jamming. And then by having that, we count the balls through the brake beam to know how many we have loading into the shooter. So then every time we shoot, we can either do a single shot, which keeps the momentum of the balls a lot better, or if we're tight on time or if we're close up to the goal and we just let all of them go through. And then this brake beam up by the shooter counts the balls as they go through, so the robot knows how many are in the conveyor currently, and then it knows which position to go into.
Talk to me a little bit more about the shooter itself. So it looks like a couple giant Coulsons on it as well. So those are very heavy, and you're running some Neos on it as well, it looks like. So, talk to me about the speed up times for it. Are you seeing, like any reductions when you have to shoot or anything like that? Talk to me a little bit more about that.
Yeah, so it only takes a few seconds, maybe 3 or 4 seconds to speed up to a good speed.
Sure.
The speed is always different. The limelight always determines the speed based on our distance and angle to the target. But and then we also have some manual control just in case one goes too high or too low. But generally it sits somewhere between 2,000 and 3,000 RPM. And we designed it this way with these 3D printed blocks. They're very thick, which is also very heavy, but it allows it to have a lot of compression force so that the balls compress almost to half size in the shooter, and it gives it a lot more force when we actually release the ball. And we have 2 Neos on there, so we have enough torque to keep the shooter going, so even though a ball goes through, it spins up to X speed in less than a second.
Well, let's head over to Sydney. It's going to be talking about the climber, and then a little bit on the drivetrain as well, too. But starting on the climber, it looks like it might have a little bit of versatility with this, so talk to me a little bit more about that.
Yeah, so pretty much it's just a simple rev lift kit that we use for the climber. It's powered by 2 rev Neos at the top, and to stop us from going back down after the climb, we use the brake mode on those motors, and it's all hooked up with our chain here, and it's actually on 6 FTC screws on these brackets down here in the extrusion. And then we also have custom brackets up here to connect the motors and the chain up here. And we do have these polycarb 2 bits up here. We originally had 2 on either side, but to save weight, we realized that we weren't using this other side as much. And so instead we cut that down and had it there just in case. But we do have these 2 on these side for it to be more sturdy as we do climb.
So your primary climb is going to be from this side?
Yes, we usually try and do it from that side. However, if there is something where we need to climb from the other side, we do have that other side.
Yeah, like that last second thing sort of thing?
Of course.
That makes sense in that. And what about your drivetrain? Tell me a little bit more what you want to highlight on that.
Yeah, so this is actually a custom Gearbox Drivetrain with 6 rev Neos on it. It is very powerful. And then we have 2 sets of Omnis and 1 set of traction wheels on the drivetrain. We also have chain and tube in here. All of this has been custom built with the chain and sprockets on the inside and our custom gearbox. And it is extremely powerful. We are not going to be pushed around, that is for sure, especially with the size, weight, and dimensions of our robot.
So last thing I want to ask you here is that, somebody who's visiting Texas, me in this circumstance, there's a lot of contention on tacos or barbecue, right? And, called barbecue. So give me your best case for why barbecue is better than tacos.
I'd say barbecue has more options. There is so many more things about barbecue, and plus, nothing's better than barbecue from Texas.
Exactly. All right. Where's the best place to go for barbecue?
Lockhart, Rudy's. Rudy's is good.
All right, so strong recommendations from a strong team here once again at the Texas Cup. Barbecue, thanks a lot for taking the time to tell us about your robot. Good luck here at the Texas Cup, and of course, I hope to see you in future competitions as well too. Thanks for taking the time.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.